Hey everybody, welcome to topic number 16, Introduction of Integers. So here we're gonna kind of take a look at some of these words that we actually need to that I kind of already talked about a little bit in the previous videos, but I want to formally introduce all these words together. Okay, these I call them different types of numbers. So in a previous video, I mentioned something called rational numbers, okay, and irrational numbers. So rational number is simply a number that can be written in the form of a over b. A over b simply means you can express it as a fraction. So we talked about where the reason why a number can be converted into a rational number is because, especially with decimals, the decimal places does and, or the decimal places has a repeating pattern. Okay, so here I come to saying the same thing. It's a rational number is a number that can be written in decimal form as a terminating decimal or as an infinite repeating decimal. So this is a better definition as compared to what you see in the previous video. All right. So fractions, rational whenever you hear the word rational, okay, it means fractions. All right. Natural number or counting numbers. Okay, this is the symbol for the natural numbers. Natural numbers always start out with one. Okay, think of natural numbers as number that naturally occur. Okay, so when a long time ago, think about when somebody see a thing. Okay, that's one thing. When somebody see two of the same thing, that's two things. Okay, so natural number things that naturally occur is one, two, three, four, so on and so forth. Okay, so because think about it, a lot of students think, okay, zero should be a natural number, but it is not. Because if you don't see a thing, how would you know such thing existed? You will not, right? If you don't know what a thing is, whatever that thing is, if you don't never sing it, you don't know such thing does not exist. Therefore, zero does not make any sense. Okay, so this is a long time ago. This is the way how people think. But as the time goes on, okay, people begin to do operations, to do things with numbers. Then here we're classifying a group of numbers called whole numbers. Whole numbers start out with a zero. Natural numbers started with one, but whole numbers started with zero. Okay, one, two, three, four, so on and so forth. Now, integers. Okay, integers are referring to as positive and negative whole numbers. Okay, so here I wrote, is coming from negative infinity actually to -3, -2, -1, 0, then 1, 2, and 3. So this is your positive side, this is your negative side. So integers are considered as positive and negative whole numbers. Okay, so it turns out the way how our number works, the different types of number works, goes like this. Okay, I'm gonna write it right here. Later on, if you take Math 108, you will actually begin to learn something called non-real numbers or imaginary numbers. So we have real numbers and non-real numbers. Okay, non-real numbers are considered as imaginary numbers. So there's actually a whole math course just on non-real numbers. Under real numbers, you have irrational numbers. Okay, this is like the hierarchy of our numbers, of our different types of numbers. You have rational numbers. Okay, so normally, if a number is a real, then the next hierarchy will be to determine whether that number is irrational or rational. That means, can you write it as a fraction or can you not write it as a fraction? Okay. Now remember, integers, all these negative whole numbers can be written as a fraction. I can write it as -3 over 1. So on the rational numbers, you have integers, you have whole numbers, okay, then you have natural numbers. Okay, you can think about the order, the hierarchy of the real numbers in this way. All right. So first thing first. Okay. Every time when we classify a number, okay, the first thing you decide is whether these are all real numbers because none of these numbers has an I in it. So first thing is to determine whether it's irrational or rational. So 7 is going to be what? Rational, because we can write 7 over 1. Okay, so that's rational. But 7 is also considered as an integer. Why? Because integer means positive and negative whole numbers. So it is also integer. All right. It's also a whole number. Whole number started with 0, then counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. So it's also a whole number. It's also a natural number, right? The difference between natural and whole number is whole number started with 0, natural number started with 1. So this is also a natural number. Okay. All right. -7. Rational or irrational? What do you think? It got to be what? Rational, right? Because I can write over 1. Is it an integer? Yes, because this is a negative whole number. Is it a whole number? No, because whole number start with 0 and counting to the right of the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it's not a whole number, then it is not a natural number. Okay, so -7 is just a rational and an integer. 2.7, rational or irrational? Rational, because I can convert 2.7 as a fraction, right? Because the decimal does end at the 10th place. Is it an integer? No, it's not an integer. Integers are positive and negative whole numbers. Okay, so it's not a whole number. It cannot be a natural number. All right, look at this decimal right here. Rational or irrational? See the repeating pattern: 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So this is a rational number. Is it an integer? No, these are decimal. Decimals, integers are positive and negative whole numbers. Okay, so if it's not an integer, it's not a whole number, it's not a natural number. Okay, whole number, natural number, difference is the 0. All right, -1.51, 511, 5111. That is not a repeating pattern right here. Okay, so that will be considered as an irrational number. If it's an irrational number, it cannot be an integer. Remember, the key word with integer is positive and negative whole numbers. Okay, so it's not a whole number. This is a decimal number. It cannot be a natural number. 0 is the trickiest one. Can you write 0 as 0 over 1? Yes, you can, because 0 over 1 equals to 0, right? So 0 is a rational number. Is 0 an integer? Yes. Okay, that's why I purposely wrote under integers, there's a 0 right there. Okay, 0 is considered as an integer. It's a negative and a positive whole numbers. Okay, because 0 is a neutral it's a neutral number. It can be both. Some people say it's neither positive nor negative, or you can say it's both positive and negative. Okay, so it's an integer. Is it a whole number? Yes, it is a whole number. It's just not a what? Natural number, right? The natural number started with 1, not 0. Okay, so that's quickly introducing different types of numbers. Now, comparing numbers. There are different ways to compare numbers. The way I normally the way I normally show students is to determine which number is bigger. Okay, it turns out it's always true. The number to the right of the number line is always larger. Okay, the right side is keep on going to positive infinity. The left side is actually keep on going to negative infinity. So positive infinity is actually greater than negative infinity. Therefore, numbers to the right is always larger. Okay, so if you know where the numbers are located on the number line, you will always know which number is bigger. So if you compare between -2 and -4, -2 and -4, who is to the right? -2 is to the right of -4, so therefore -2 is larger. Okay, if -2 is larger, I use this inequality. Okay, this inequality because the open mouth faces the larger number. Okay, that's how you know which one to use. Okay, now let's be clear. A lot of people say this is less than, this is greater than. That is not true. That is only true if you read it from left to the right, reading from left side to the right side. Okay. So if you read it, if you read it from the right side to the left side, okay, then this is no longer less than. Okay. So when we begin to introduce algebra, okay, we will talk more about, how to view the inequality. Okay. I don't always say this is less than. Okay. Just like, for example, I'm just making something up. If you read if you read from left to right, this is saying what? X is less than 2. But if you use the same symbol, but just switch the X and the 2, okay, now this time if you read from the right side, this is actually reading as X is greater than 2. So you're actually saying two different things here. They're not equivalent. Okay. So if you say X is less than 2, then what happened if I would write it this way? Now, if you read from X, X is what? Less than 2. So now you're saying the same thing. Okay. So it's a little bit confusing. Okay. Just understand that these inequality symbol, okay, it all depends on which side you're reading from. Okay. To determine what was the word you used for it. All right, -6 compared to -6.1. Where is -6? Right here, right? Where is -6.1? Is to the left of it, of -6. So -6 is to the right, so -6 is larger. So if -6 is larger, the open mouth face is what? The larger one. Okay, now we've done this one before. How do I compare two fractions? Well, we compare the numerator. But before we can compare the numerator, we got to find the LCD between the two. LCD between 5 and 3 is 15, right? All right, let's increase our numerator. 5 going to 15 3 times. 4 times 3 is 12. So you can say the numerator here is -12. The other side, times by 5, times by 5, right? That'll be -10. So I'm basically comparing between -12 and -10. Who is to the right? -12 and -10 is right here. -12 is actually somewhere to the left of it. So -10 is bigger. All right, if -10 is bigger, that means the fraction on the right side is bigger. So which one of these two inequality do I use? I use this one. The open mouth space is what? The larger fraction. Okay, so if you read from left to right, -4/5 is less than -2/3. If you read from right to left, -2/3 is bigger than -4/5. Okay, you're saying the exact, both statements are true. So you're saying basically the same thing, just reading it from a different direction. All right. Let's quickly talk about absolute value. What is an absolute value? Absolute value, after all, is referring to the distance. A number is from 0 on the number line. Okay. Now on the number line, if I go to the left, okay, all the number to the left side of the 0 is negative. I do agree with that. Okay. But if I ask you, okay, how far is -4 to 0? Or how far is 0 to -4? What would you say? You would say 4 places. Okay, the 4 you just said is a positive number. That's the reason why every single number coming out of the absolute value is always going to be positive, because absolute value is referring to the distance. So absolute value of -4 got to be +4. Absolute value of 4 got to also be +4. Okay, whatever come out of absolute value is always positive, because absolute value is referring to the distance of a number from 0 on the number line. So that being said, if I will put an x inside the absolute value and say this is equal to 4, what do you think I can put for x? What do you think I can put for x? Well, x, this number inside absolute value, can be either -4 or +4. because both -4 inside or +4 inside the absolute value will always come out to be 4. Okay, so x is equal to -4 or +4. All right, let's compare these two. Are they equal? They sure are. Because absolute value of -7 is +7. Absolute value of +7 is +7. So the two numbers are equal. Okay. All right, same thing right here, just like I did with the absolute value of x equal to +4. So what number can I put inside the absolute value for x that will come out to be equal to 3? That's what this means. I can put -3 and I can put what? +3. So those two are my answer. What number I can put inside the absolute value when it comes out will equal to -6. That would come out to be equal to -6. Nothing. It does not exist because the number, whatever comes out of the absolute value, got to be a positive number, not a negative. Okay? It don't exist. Whatever come out of absolute value got to always be positive. It cannot be negative. Okay? So absolute value can never equal to a negative number. All right. Let's take a look at just plotting some numbers on the number line. -5/2. So 5 divided by 2 is about -2.5. -2.5 is between what? -2 and -3, right? So they'll be right there. -3 is right here. 5/2 is 2.5, which is between 2 and 3. And 4 is right here. So this is an exercise. I want to make sure, you know where all the numbers are on the number line. Okay. It says graph. It's more like a word plot. Well, maybe graph. Maybe plot is a better word. Plot all integers less than 4. All the integer. That's the key word. Is the word integer. Remember, integers are positive and negative whole numbers. Okay, so I only want to plot integers. Nothing in between. Just integers. Less than 4. Okay, less than 4 does not include 4. Okay. Remember, integers, just integers, not decimals. Okay, because integers are positive and negative whole numbers. So 3, right? 3 is less than 4. 3 is an integer. 2, 1, 0, right? 0 is an integer. -1, -2, -3, all the way to what? To negative infinity. Okay, that's what that means. Plot all the integers. So I'm using solid dots representing all the integers. Okay, some student will do a highlight all the way across it. That will be incorrect because when you highlight everything in between the integers, you're also including all the decimals. Okay, but this problem won't only want me to do integers, so just the integers being plotted. All right, this is a good exercise. All right, let's take a look at some of these homework problems. A natural number starts out with what number? What natural number start out with? Let's go back up. Natural numbers start out with who? 1, right? All right, classify the following numbers. So classify 0, okay? Enter all that applies. Okay, so I need you to enter the answer inside the box, okay? Separate them by, please separate them by comma. So we already went over this earlier. On the number line, or real numbers, on the real number line, numbers to the right is always what? Then the number to the left is always what? Greater. Number to the right is always greater than the number to the left. All right, absolute value is, let's go by definition, is the distance of a distance a number is from 0 on the number line. Okay. All right, so enter in the box. All right, consider the following equation. Find the real number that satisfies the equation above. So this is me asking you, what number can I put inside the absolute value for x? so that it will come out to be a positive 10. Okay, separate your answer with a comma. All right, instead of graphing, use the graph below as a reference. Okay, let's use that. I'm using this picture as a reference. Enter all negative integers less than or equal to -5. Or equal to -5. Okay, so please, so this is the way how I want you to do it. Okay, so less than or equal to -5. So I'm starting with -5, right? -6, -7, so on and so forth. Okay. Then you're gonna write it. You're gonna enter -5, -6, -7, -8, -9, -10. Then you're gonna say comma. After -10, you're gonna say comma, -infinity. Okay. You know what? Let's do it this way. Let's do ... Let's do ... -infinity. How about that? Okay. So type in. So I would like you to enter -5, -6, -7, -8, -9, -10, comma, ... comma. Let's put another comma right here. 3 dots and a comma. It's a better way to write it. And then enter -infinity. Okay. That would be good. Yeah, maybe not. Maybe just do ... -infinity will be fine after the dot. You don't need an extra comma. Okay, so that just so this showed me that you understand that, hey, there's negative, there's infinite number of integers. Okay, that's less than or equal to -5, right? There are infinite of them because you keep on going to the left. So just enter 6 of them for me, or enter 6 digits and the -infinity sign. Okay. Now, if you don't see sometimes when if you don't see the symbol show all components, the 3 dots I asked you to use in D2L where you will enter the fraction for me. If you don't see this, then you don't have to use the -infinity sign. Okay, you just need to do ... That will be fine. All right, so that will conclude this video. Thank you for watching.